I just saw a talk on large language models, and there they explained that context is important. So I will provide the context, and then Ruud will go into the details. Imagine that you are a civil servant working at the municipality, and you get a question about how safe are your roads. Can you give me all crossings, and can you see how safe those crossings are? Can you put a number to it? If you have a small village, this is doable. You would go out and you would look and do some measurements, and then you get back and say, well, it's pretty safe. It's put a number to it. So if your city gets larger, this doesn't scale very nicely. And so what we do as a company is we try to enable those professionals to do their jobs better by providing a more safer and sustainable way of doing this. And how do we do that? We do that by acquiring lots and lots and lots of data. So we do large-scale mobile mapping. We drive around with these cars. We take pictures. We take point clouds. And we get accurate location of these devices. And what we then do is we get information out of those point clouds. So today, with all these cars, we cover the entire Netherlands. We take all the data that's out there. We process the data in a private data center. And we make it, we call it AI ready, but we pre-process it so it's nicely indexed and searchable, and you can actually use it to do some data science. We have AI models that that identifies assets, and by assets I mean traffic signs, light poles, markings, these kinds of things. And then we prepare them so that professionals can actually use them in the field. Where we want to go, of course, is take all of this data that we get, start crunching it, and get foundation models, more searchable data, and try to map the entire public space. And we want to do that on a very large scale. We started with the Netherlands this year. So we mapped 150,000 kilometers of roads. We take pictures every 5 meters, so it's an immense amount of data. And what we did is we identified proactively all traffic signs in that data. So it's about 6 million traffic signs. And we delivered that to the professionals that can then act on that data. And this is just the start. So if it's up to us, we get all other assets out, and we will expand internationally as well. Comes with a lot of challenge, scaling mostly. So all these nice AI models we want to scale. So it has to work on a global scale. But we are also thinking about privacy, data sovereignty. So we process it in local data centers. So on one hand, we want to scale globally. On the other hand, we have to locally build that infrastructure as well. And with this also comes scaling hardware, buying devices, shipping them everywhere, and having the people to do it with, which is actually the most important part. So how do you scale from a small organization to a bigger organization? And how, with all the changes that come with that. So lots of challenges. The challenge here that we are going to address is that of the data, AI, point clouds, images. We focus on that in this talk. But people are the most important aspect if I would say what brings us the most. And with this nice picture, I will hand it to Ruud.
All right. Yeah. Can I get the device? All right. Hello, everyone. I want to take you on a small tour on asset localization. But first of all, please stand up, everyone. Just come on. A bit of action. Yes. Thank you. Wait, do it the other way around. Now everyone's standing. I want to see some hands, but I want to know, I'm not going to assume anything. Who of you has ever worked with computer vision? Who has applied computer vision models? Okay, good. Who knows what is a point cloud? Perfect. Okay, this is really good. Who has worked with point clouds before? Okay. Who has worked with both computer vision and point clouds? Okay, getting smaller. Something with geospatial. So who has worked with GNSS, INS, localization, all that? Good. Okay, nice. All right, thank you all. Just sit down again. That's yeah, I don't know what the standing up was for. I'm going to give you a small tour on asset localization. What we're going to do is we're going to show you how to find an asset anywhere in the world. And what we mean with asset, it's just it's a thing, an object. A thing can be anything. What we consider to be an asset is everything on and around the road. So what you can see from the car that we have. It can be a light pole, guardrail, traffic sign, tree, road marking, everything that's related to infrastructure on and around the road. We consider things in 2D and 3D, and I'm going to give you well, example of both. I'm going to focus mostly on traffic signs, so everything that's not flat on the road, but it's upward. Let's see. Yes. This is what a traffic sign looks like to us. This is from a product design session. What you see here is all the attributes that you could map from a traffic sign. Where is it? How high is it? How many signs are attached to it? What is the carrier? How far is it from the sidewalk? Is it standing upright? What is the direction the thing is viewing? Really everything. There's a crazy amount of things that you can tell about a traffic sign without ever thinking about it. And we know them all. With the picture, with the surface area and everything. And this is the thing we will discussing a bit about. Now, when you want to find all traffic signs in the Netherlands or in any country really, you need to have that data. Right now, we have data for all of the Netherlands, every street, every corner, every parking area. Last year we did that, this year actually. When we started with this whole journey, so we want to find assets. When we started with this journey, we first reached out to companies that already did this. So we collaborated with partners and saying, hey, if you have this data for us, we will find you all those assets. This is what we got. And people were asking us, can you find me the damage or the amount of repairs that I have to make in this area? I said, well, maybe, maybe not. So you see, what you see here is an orthophoto, or in the first talk we had this morning from Jordi he was showing us satellite images, and this is sort of recreating that, right? It's an orthophoto. It's a thing that we generate from the camera that we have. So we take a picture every 5 meters. We project those images as if you were looking down from a satellite or from a plane, and then it creates an orthophoto. So this thing's supposed to be smooth, nice, and all. But you see here that there's distortions, things are out of place, it's wrong in every way. So this doesn't work. What do? You calibrate your camera, right? System is not performing, something must be wrong, it must be your camera. We calibrate cameras. And this is real, we did this. So the way we calibrate, this is, don't do this. But it's a hard problem. And just to indicate how hard it is, there's different coordinate systems that you have to take into account, and some of you probably are aware of this. You have your 3D objects in the world, right? There's a thing, an asset, a traffic sign. You have your camera system on top. That has a coordinate system. There's a world coordinate system. There's the car itself. The car itself is moving. It's driving over speed bumps and whatnot. Drivers are, they want to get home, right? So they're driving fast. Then there's that image that you get, and the points you project onto this image. It's a hard problem to calibrate all of that and to align it all. And when we started with all this, we had this idea of just using camera. We can locate an asset with just images, right? We can do that. And it is possible, you can, with this type of theory. So if you calibrate your camera, all your system, everything looks good, then what you could do is every pixel in your image, create a vector through it in 3D space. And if you have 3 of those, then I know where that asset is, right? If I intersect those 3 lines, I know where it is. That's the main theory behind it. And it works, so in theory. So all the intersecting lines is where an asset is supposed to be. But you can already see, you can already see there's more intersections than you would like to have, right? Because in an image, by default, you can't see depth. Of course, there's mono depth and all the other algorithms, but they give you a relative distance and not an absolute distance. Okay, there are some absolute distance models as well, but in just working with images, that's going to be a challenge. Now, there's a paper, 2018 paper from Krylov that describes this very problem, and it says, if this is your approach, then this is how you can solve it, and it works. So you can do this if you have these intersecting lines. So you have your camera position over here, camera position over here, over here. So we take a picture every 5 meters. There's an asset, an object that we're looking for over here, here, and here. And from all of these locations, you've seen all these assets. Now you have these intersection lines. With this theory, you know how to find the location of these assets, right? Everything good, everyone happy. And it knows how to rule out these ways. So it's using a Markov field, and it works. Except Markov was a smart guy, but he doesn't, well, reality is a bit more chaotic. Okay. Yeah, reality is chaotic apparently, I don't know. This is what reality sometimes look like. So in theory, you have just a few intersecting lines, but what happens if you go out there and you find detections, this is the thing you have to solve, right? Then even the best paper, the best algorithm about it doesn't really work. So that was a problem, and still locating an asset using these intersecting lines, that's not really going to work. So let's go 3D, add a LiDAR, right? Let's add depth to it so that you can even know where to stop with these intersecting lines. And yeah, going back to that fleet of cars that we have, here you see the main components. So we have a camera, GNSS antenna, yeah, main car. This you didn't see in the pictures is a wheel sensor. This is the one of the sensors that you maybe have used using a robot car and as a kid that you can use odometry, right, to measure how far the thing is. This one is important, by the way. But this is what we added. We added a laser scanner, a LiDAR scanner, generating point clouds. And this thing scans at or it can generate up to 600,000 points per second. So it's a lot of data. It doesn't, in reality, it doesn't do that, but it's well, it generates a lot of data. And a funny story about the car itself. You see here AVG proof. That works in the Netherlands, but there was a time when we were at an international conference, and so we were thinking big, and we are thinking big, and we are out there. We put a car in the booth, right? We had this car there, and I had a very serious conversation with someone. Oh, sorry, thanks. I had a very serious conversation with someone regarding what we do, and at some point, they was asking, "What is average proof, man? What's average proof?" Okay, that doesn't work. So of course it needs to be GDPR proof if you go international. But this is on every car in the Netherlands we have a sticker called average proof. Yeah, so we added LiDAR, and that is made to overcome the issue for asset localization. Okay. Not yet, right? So we add LiDAR, we tried to integrate it, didn't really work. So this is all the examples. Most of the examples I'm giving you are from Ring Groningen, the first time that, or in and around Groningen. So what we do, we add a LiDAR, go on to Ring Groningen again, capture some data, look at it. Yeah, doesn't look good. So this is some images that you see from debugging and whatnot on getting there, aligning those sensors and calibrating these sensors. With a bit of effort, in the end, we did it. It worked. So this is near Asse. There's a roundabout near Asse, and you can see that this aligns well now, right? So you overlay point cloud on top of your images, everything fine, everything good. For every point in this image, we know exactly where it is on Earth. So we know the 3D location on Earth because we use the GPS antenna, INSS in the car. Yeah, so we know exactly what it is. So by that, now we also know exactly where all those pixels are. Good, problem solved. You can do it the other way around as well, right? So here we are projecting point cloud on images, but you can do the other way around as well. You can project, you can colorize your point cloud with the data from your image, right? You can do both ways. Not sure if some of you remember this one. This is the old Julianaplein in Groningen. In Groningen, this has been replaced all, but this is the Julianaplein. It's and here we do it the other way around. So this is a point cloud again, but then colorized with the images from it. This is old. The image is old, but also the whole thing is old. Yes, back to assets. So what we did, where we are right now is we have a colorized point cloud. For every point, we know exactly what it is on Earth. For every pixel in your image, you thereby also know exactly what it is. So we can use the everything we know from image, we can apply it on our data, right? So if you're good at computer vision, you get a few extra tools now because you know exactly what it is. You can measure volumes, location, height, everything, and that's exactly what we do. So from these type of point clouds, clients of us, contractors, municipalities, they ask, can you give us the locations of traffic signs? Sure, we can, and that's what they're looking for. So we mask these things, we find those locations, and what is so annoying about all these things is that this point cloud, it looks so rich, so powerful, so strong, so immense amount of data. The client only wants one dot on this location. So instead of having 16 million points, they only want one, saying my traffic sign is over here with a few attributes to it. But that's what we have to deal with. So yeah, this is how we find these assets that are above ground. That's we find the location of these things. Through computer vision, right? So we apply computer vision, match it with point cloud, and then we find the locations of these things. We know a whole lot about these things now because we have point cloud. So we also know, we can even predict, if you will, when the thing is going to fall over at a storm, right? Because we know the carrier itself of a traffic sign. We know where the carrier location is. We know the surface area of the sign. We also know the facing direction of a sign. If you know that the storm is coming from one direction, you know what a carrier can take. We can already predict you. You're probably going to want to have a look at this the day after tomorrow because it's getting windy. You can do all kinds of fun stuff with this. Going back to 2D. Well, not really 2D. This is from a point cloud again. This is also Groningen. So you see, you'll probably recognize it. This is the Oude Ebbingen, I think, right? Yeah. We are here, I believe, somewhere here. So this is data. I took a small sample from Groningen and projected on this thing. So what you can do is you can look at this data through different channels as well. This morning we had a chat about satellite data, which had 10 different channels. We have a couple as well. So what you see here is that with the right filters, with the right settings, you can extract other attributes as well. You can measure reflectivity, you can measure all kinds of things. And this is how we find flat things on the road, right? So here you can easily find road markings, for instance. So there's you can do more than just the above ground things. Yes, and we can do. I think the most important message about all this is that we can do this at scale. This is I zoomed in on Groningen, zoomed in on this, but you can zoom out all the way to the Netherlands, and you get a map from the Netherlands. We did that last year, so we have this, but for a whole country. You can do it, and the concept that we have is. So we see Netherlands as a playground, as a concept, and we want to roll out everything of this in the rest of the world. So we want to enable partners internationally with this idea. So you want road markings, you want traffic signs, you want whatever asset you want. We've got you covered. That's the mission we have. One more view of Groningen city center here. It's not a very nice picture, but this is how you can see how a point cloud with different intensity or what is it, different channels, looking at a different channel, and later looking at an RGB channel. On top of it, you will find a layer. So I've been stacking a few layers in this image. Yeah, all right, thanks. I've been stacking a few layers here. So you see a regular point cloud, RGB, and you see the locations of traffic signs all in one image. This is that same roundabout this is that same roundabout in near Assen. Let's see if I can make that work. Yes. The cool thing about it is that we can also combine it with third-party sources. So we don't only have to go about looking at this at our own data, but what you see in the background is, okay, I'll do it again. In the background, you see data from it's aerial data, both LiDAR and imagery combined. And on the road, okay, can I maybe pause it for a minute? Pause. Yes. What you can see here is that we extracted road markings. That's the bluish lines from this image. I have the same thing with additional layers as well for traffic signs and whatnot. But yeah, for this thing, it's mostly to highlight that we can combine it with third-party sources as well. Okay. Yeah, I'll skip a bit forward a bit. This is yeah, looking at the future. What we are thinking and working on is a point cloud foundation model. So we are strong in computer vision part. We have a lot of background in that, and there's also a lot of resources available for this, and everyone yeah, is familiar with it. A lot of research on computer vision. Little less on point clouds, but yeah, we are using both. So we are using both computer vision models and point cloud models to extract these things. What we are envisioning is co-pilots in a 3D environment. So we have a 3D web environment where you can view, measure, navigate through this data. What we envision is that there's going to be that same platform, but with code pilots integrated, so that you can ask it a question as in, hey, AI, can you give me, I don't know, the number of traffic signs in this neighborhood that are damaged or need to be replaced? Can you give me the quality of this road? Can you give me, well, you name it, right? That's the interactions we're going for, and becoming the geospatial search engine. And that's also why how I would like to conclude. So I have one thing. So one question I also had, or can imagine that you would have for such a AI is, if you're on a journey towards a venue, forum, for instance, and you need to park there, and you're a bit late, right? You need to, yeah. So AI, can you please give me a view of the location I'm gonna need to park in a bit, because I'm late and I don't know if I trust my navigation system fully. So just render me a location. So what you do is you enter the St. Johnstraat, you go left on the Schoolstraat, and then, no, unfortunately it's not, no. And boom, there you are. There you parked your car, and that's it. The traffic signs is one of those layers that we have there. So you get a nice overview of where you need to park. That final part of your for your trip. And with that, I want to say thank you. But most of all, I want to say thank you to the team that made this all possible. I see some Nolan, Ruud, Sjors, Frank, Jeroen, of course, and in the audience here. Some of us are present here today, and but if you have any questions, just reach out to us. And yeah, thank you all. Thank you mostly for the team. So. Yeah.